Hi, this is John. This video is about basic electronic wiring for use in rockets. I'm standing in my shop, but we're going to spend most of this sitting down at a table. Let's begin.
So just to be clear, this video will not help you with your electrical contractor's license. I'm talking here about electronics for rockets. We'll talk about batteries, switches, not much about electronics themselves, and just touch on electric matches. What we're really talking about in this video is how to connect these pieces together securely and reliably. The traditional batteries used in rockets are the plain old 9-volt. Almost all older units are set up for these. Increasingly, lithium polymer batteries are becoming the preferred choice. They're rechargeable and have low internal resistance, so they're capable of putting out large amounts of current when you need it. 3-cell LiPos can be used as direct replacements for 9-volt batteries. And 2-cell LiPos work with newer electronics that don't need quite as high a voltage. Traditionally, standard panel switches, such as toggles, push buttons, or the slide switch you see here, were the common choice. More recently, the shorter voltage selector switches have become the standard for their reliability and ability to pass large amounts of current. Another good option are screw switches, such as this one from FingerTech Robotics. Of course, the best switch is no switch, and sometimes you can arrange that you don't need one. For example, here I have a hatch, so I can arm the electronics, keeping the orientation the same, and install it into the rocket right on the pad. No need for a separate switch. Anyway, let's get back to wiring. Here are some basic tools you'll be needing. Soldering always seems to require 3 or even 4 hands. You'll want good wire strippers that will cleanly remove the insulation without damaging the wire inside. Diagonal cutters are always a necessity. Make sure they're sharp and the edges are clean, and you use them only for cutting wire. And a soldering iron with a pencil tip. Especially if you're soldering indoors, make sure the fumes are adequately vented. And some basic supplies that we'll be using. Heat shrink tubing seals soldered joints to avoid shorts. Battery connectors are of course necessary. And stranded hookup wire is really easy to work with for making extra connections. Soldering is not terribly difficult, but there are a few basic techniques that will help you get much better results. The first tip is to actually use that little sponge that comes with your soldering iron. The first joint we'll learn is a Western Union splice. This is a great way to join 2 pieces of wire end to end. First off, strip about 1/2 to 3/4 of an inch of each piece of wire. Now for the splice itself. Cross the wires over about halfway along the stripped length and twist them around each other. You want each wire to be twisted around the other one, so together they form a nice solid joint that stays together by itself. Second tip is never try to solder by holding more than 2 things in your hands. Now for the actual soldering, we first turn on our fume trap, clean the tip on the wet sponge, and tin the tip by melting some solder onto it before we begin to solder. Now when soldering, we want to apply the heat from the tip to the wire, and we also want to melt the solder into the wire. So we don't necessarily want the solder to touch the tip, we want them both to touch the wire. This will cause the solder to thoroughly flow into all the strands of the wire, making the bond strong and solid. And finally, to finish off the joint, we want to cover the exposed area of the splice. This just protects it against shorting out in any situation where the wires get pushed together. The heat shrink tubing slides right on over the joint, and then we can use a heat gun on low setting to shrink it and make it a tight fit all around the joint. And there you go. That's how you create a strong, solid, and clean end-to-end splice. Next up is soldering to a switch terminal. Here we're going to use a Schroeder voltage selector switch, but the technique is pretty much the same with any switch that has solder-on lug terminals. So the first thing you can do with these is clip off the outer two terminals, leaving the inner two, which act as a single pole on-off switch. Once again, strip about 1/2 inch of insulation, slide on our heat shrink tubing, and now we'll thread into the solder lug and twist around. We want to actually twist the wire back around itself so it makes a nice strong bond. And then once again, set our part securely in the third hand so it's easily manageable. And then we can begin soldering. Clean the iron. Tin the tip. And then again, apply the heat to the lug and the solder to the lug. And then once again, we should have a compact and solid joint where the solder wicks into all the strands of the wire. Now let's finish it off with the heat shrink tubing. Once the part cools a little, we can slide the heat shrink tubing down over the lug and shrink it to size with the heat gun. And there we have a clean and solid joint. The third connection we'll look at is finishing wire ends to fit into screw terminal blocks. Strip about 1/4 inch of the end of the wire and, as always, hold it in your third hand. Now this should be a mantra. Clean the tip, tin the iron, and solder the part by heating the wire, not by melting the solder directly. So now when we install the wire into the terminal block, it's solid, and when we screw down on it, it won't deform. As a result, we'll have a solid connection. Now let's put this all together and see how a complete electronics bay works. This electronics bay was built for my Crayon bank rocket. On the front we have space for the RRC2. On the side we have a mounting plate for a switch, and the battery mounts on the back. Here's the wiring harness, a very standard arrangement with a battery and a switch interrupting the positive lead which goes to the electronics terminal block. And here's everything mounted on the electronics bay. The MissileWorks RRC2, the Schroeder voltage selector switch, and on the back, most of the wiring, including our battery and the wiring to the switch with the leads running around to the front. Now the last little bit of wiring is, of course, the ejection charges. I like to tie a knot in them to act as a strain relief. That way, if the wire is pulled, it doesn't put stress on the joint where the wire screws into the terminal block. I told you before to use wire strippers to protect the wire. While that's important with stranded wire, it's really critical with solid wire. If you nick the solid wire, it will have a high likelihood of breaking, which will be terrible. If your ordinary wire strippers are too coarse for these wires, you can use special strippers that are made for finer wire and solid core wire. And once the wires are mounted into the terminal block, give each one a little tug to make sure that it's securely in place and it hasn't been nicked.
So I hope this video was interesting, even though most of it was sitting down. Anyway, happy soldering, and as always, have a great flight.